Okay, so now we'll be attempting problem 8 on the F equals MA 2026. So I'm going to read out the problem quickly. A puck of mass small m moves with speed v towards a heavy bump of mass big M, where big M is much greater than small m. Both the puck and bump slide without friction. The bump moves toward the puck with speed v over 2 and provides a smooth transition from the horizontal surface onto the bump. The bump is tall enough that the puck slides back down. Find the maximum height h the puck reaches. So right now I'm just going to draw a quick diagram. We can see our puck here and our bump, and we see the two velocities. Now it's pretty easy to tell that these two are moving towards each other, which becomes more apparent later on, but for now we'll just move on. So let's look at this. What is the first thing we notice? Well, we're trying to convert information about velocity into information about height. Whenever you see that, you want to think about conservation of energy. Energy is conserved. Now what that means is that the final energy is just equal to the initial energy. Now, our initial energy is velocity. And what energy includes velocity? Kinetic energy, obviously. And our final energy is about height, so it must be gravitational potential energy. So we plug in those two formulas, mgh and 1 half mv squared, and we get that they must be equal to each other. Now we can cancel out that m, and we just get gh equals 1 half v squared. Now with some algebraic rearranging, we can get h equals 1 half v squared over g. Now let's put that aside for a second, and let's focus on how we figure out that v. So what we can see is that these two things are sliding towards each other, but we still have to figure out what our relative velocity is. Now, the best way to figure out relative velocity is to choose a reference frame. You pretty much always have to do this. Now, what would the best reference frame be? Well, in the question, they told us that big M was much larger than small m. The reason they would have told us that is so that we know that when big M and small m collide, small m will move a lot more than big M. Big M will probably barely move. Now, how that helps us is it makes that inertial frame easier to calculate. Big M will be much easier to calculate than small m. So now we can calculate the relative velocity relative to big M. Since they're moving towards each other, we can just add their velocities, and we get the velocity as 3v over 2. Now we'll bring our equation back and plug in that 3v over 2, 3 over 2v. Yeah. And we'll simplify to 1 half times 9 over 4 v squared over g. Now further simplifying, we get 9v squared over 8g, which is just our final answer.